In this session we are going to discussing about heaps and what are its types and how to insert the element into the heap sort method and how to delete the element into the heap sort method. We'll see one by one. Before going to head with the next topic, I'm going to explain you what is a heap. Heap is nothing but it's a complete binary tree. Already you know about what is a complete binary tree. Complete binary tree is nothing but all the levels should be a what? Equal. Suppose I'm going to draw A, B, C and D and E and F, G. See here how many levels are there. So this is a level 0, this is level 1 and this is level 2. Okay, there are the 3 levels, all the levels are equal. Okay, see here again there is no child is there. Okay, so all the levels are should be equal. So heap is also, I can say that's a complete binary tree. Okay, now there are the 2 types of heaps. The first one is max heap and another one is a min heap. Okay, so what is a max heap? Max heap is a nothing but, suppose I can see the one example. Assume that there are the 2 nodes are there. Okay, so A and B. Okay, so this is a A will act like a parent, B will be the child. Okay, so in a max heap always the parent node should be a greater and child node should be a smaller than that one. Okay, so which is a parent node here? A is a parent and B is a child node. Suppose I can write that parent of A should be a greater than or equals to child of B. B is a child node, A is a parent node. Always parent node should be a greater than its child nodes. Either it may be a left child or right child, it doesn't matter. So always parent should be a what? Greater than its child. That is the rule for what? Max heap. And what is the rule for min heap? Min heap means nothing but always the child node should be a greater than its parent nodes. Okay, suppose I can write the syntax: parent of A should be a lesser than child of B. Okay, min is going to be opposite of this. Max means parent node should be a greater, child node should be a lesser. But in min heap we can say the parent node should be a lesser than its child nodes. That is the rule we are going to applying for the max and min heap. We'll see the examples with how to insert the element into the max heap and how to delete the element from the max heap method. Okay, we'll see with the example of heap sort method. Okay, so this is the given equation to construct the heap sort method, or you can say Hepify method also. I have drawn the array here for these elements. So totally there are the 8 elements are there. We'll see how to solve this equation. Okay, the first step. So what is the first value? That is a 13. 13 will be, I'll write it here. Okay, what is the next value? 86. In the second step, what I will write? 13 and 86. Okay, now this we have to done. Why you have to write it left? Always complete binary tree will have to write first left after right, and left and right we have to go like this. That is the way of complete binary tree. We have to go with according to the rules. Okay, so now check out the Hepify method rule. So what is the Hepify method rule? Parent node should be a greater than its child node. Okay, see here the parent node is a smaller than this child node. What we have to do, we just swap the 2 elements. Okay, so 86 will come here, 13 will goes here. Okay, now what is the next value? The third step, 86, 13 and next is what? 43. We after left we have to write the right tree. Okay, now check out the rule. These are 2 child node, this is a parent node, this is a smaller than this node, so rule will be accepted. No need to change, right as it is. Okay, next in the next step, what is the next value? That is 38. 86, 13, 43, and here after completing this level we have to insert for the next level. Okay, so what is the value we are going to inserting? That is 38. Insert it. Now check out the rule. Whether 38 is greater than of this 13, what we have to do, we just swap out the elements. Okay, so 32 will goes here and 13 will come here. Okay, now check out these also. These are two smaller than this parent node, the rule will be accepted. Okay, leave as it is. Next is what? 54. Okay, in the fifth step, 86 write as it is. So after left we have to draw it to the right. 54 is the next element. Okay, now check out these are two child node of this parent node. So this child node is a greater than of this parent node. What we have to do, we just swap the two elements, just swap the elements. Okay, so 54 will come here, 38 will goes here. Okay, now check out these also, 54 and 43 and 86. Okay, 86 is a greater than of these two numbers, the rule is accepted, so no need to change, leave as it is. Okay, next in the next step, sixth step, what is the next value? 23. Okay, insert it. Remaining values will be right as it is. Okay, next value is what? 23. So where we have to, after this left, after we have to write right subtree. Okay, 23. Okay, we have to insert. Check out the rule. This is a smaller than this root node, so no need to change, no need to swap, write as it is. In the next step, so 8 I have to push it here only. These two child node, this is a parent node, so need to change, write as it is, no need to exchange the values because the rule will be accepted. The last node is what? The 8th step, we have to push 63 here. Okay, 86, 54, 43, next is 13, 38, 23, 08. Where we have to insert that 63 now? We have to, after this level is completed, again we have to go with the next level. We have to draw left subtree itself. Okay, we have to go with the here. What is the value? 63. Okay, just check out the rule. This is a child node and this is a parent node. The rule is not accepted. We just swap out the two elements. This will goes here and this will come here. Okay, so 13 will come here, 63 will goes here. Okay, now check out these two rules. Okay, these are two child node and this will be act like a parent node now. Okay, so the rule is not accepted, we just swap out the element. Okay, now 54 will come here, 63 will goes here. Okay, now the condition is accepted, no need to check out here also, that's also accepted. And check out these two are the child node of this parent node, that is also true. So this is how we are going to inserting the values into the heap sort method or Hepify method. Okay, now I'm going to show how to delete the element from this Hepify method. We have constructed a tree now. Okay, so there are the two rules. Okay, the first one is to construct a heap tree. We already constructed the heap tree. Okay, what we have to do, second step is to delete a root node. Okay, so what we have to do, we just delete a root node from the constructed heap sort method. Okay, so which is a root node here? 86 is a root node. We have to delete this. If I delete this 86 from this tree, so what will happen about the remaining nodes? Okay, so which is the last node among this complete binary tree, that node should be replaced as a root node here. Suppose I deleted this 86 and this 13 will goes here. Okay, so 86 will be deleted. Where it has to store? It has to be stored in the here array. Okay, I have taken the array early, as I told that there are the 8 elements, so I have represented with all the elements with the array values. Okay, so that 86 will goes there. Okay, now check out the rule whether it is a satisfy that heap sort method. So what is the rule for heap sort method? The parent node should be a greater than of its child node. Check it, the parent node is 13, child nodes are these. The rule is not accepted. What we have to do, we just swap out the elements. This will goes here and this will come here. 13 will come here and 63 will goes here. Okay, next check out these rule also. So these are the two child node of this parent node. What we have to do, 13 will come here and 54 will goes here. They will exchange the values. Okay, now After this we have to check out these also. These are two child node and this is a parent node, this is also accepted. These two child node and this is a parent node, this is also accepted, no need to change. Okay, now in the second step we have constructed the tree. The second step is delete a root node. Again, which is the root node here? 63 is a root node. We just delete this 63 from the tree. Okay, we are storing into the array. Okay, delete this 63, which is the last node among this complete binary tree. 8 should be replaced as a root node. Okay, now 8 will be a root node and 63 will be removed now. Okay, so this tree will be, this node will be a deleted. Okay, now check out the rule. These two are the child node and this is a parent node. Check out the rule of this. So again we need to swap the elements. 54 will come here and 08 will goes here. Okay, next, after that check out these rule also. So among these two, this 38 is a greater, we have to replace it again. 38 will come here and 08 will goes here. Okay, now check out this also. The condition is accepted, no need to swap. Okay, leave as it is. We have constructed now. After constructing the tree, what we have to do? Delete a root node. Which is a root node now again? That is a 54. 54 we are just deleting the root node. Okay, we are just deleting the root node, which is last node among this heap sort method. 23. So 23 will be a replaced here. Okay, this node will be a deleted. Okay, now. So after this, check out the rule of these two. Among these two, 43 is a greater. The 42 will come here and 23 will come here. These two will be swapped here, exchanged. Okay, now check out these two. These two are smaller than this node, that will be accepted, and these two also smaller than this node, as the rule is also accepted. Now after deleting this one, again constructed the tree. This is a constructed tree now. Now after that again we have to apply the second step, that is a delete a root node. The 43 is a root node now. That 43 will be deleted and goes into the array. Okay, so this 43, which node we have to replace? The last node of this complete tree. The 08 is a last value of this heap sort method. Okay, this value will be erased. Okay, now after this we have to check the rule. Okay, so 38 is a greater than of this value, so we have to just swap out the value. Okay, 08 will come here. Okay, now check out these also, and this is a larger than this node, so what we have to do? We just swap the values. 13 will goes here, 08 will come here now. Okay, after the next step we have constructed. Next step is what? Delete a root node. After that, which is a root node? And this 38 will be a what? Deleted and stored into the, which is the replacing node, the last node of this complete binary tree. The 08 is the last node, so this 08 will goes here and this value will be erased. Okay, now after this, check out the rule of this Hepify method. So what we have to do? Among these two child, 23 is a greater, 23 will come here and 08 will goes here. Okay, we just swapping the elements. Now after that we have constructed a tree. Delete the root node. Which is the root node? 23 will goes here. Again you just delete this node, which is the smallest among the, which is the last node of this tree. 8 will be replaced and 23 will be what? Removed. Now after this, check out the rule of this. Again child node should be larger than parent node. We just swap out the elements. Okay, 13 will come here. Okay, so which is a root node? Again 13 will place it here. We just delete the node. 13 is also deleted, which is the last node of this tree. 8 will be replaced here. 13 will be erased now. Okay, now after constructing the delete a root node, this is a root node, delete it, 08 will come here. This is how we are going to constructing the heap sort method, or we can say Hepify method. We have to construct the tree, we have seen that also. How to delete a root node, that is also we have seen. See, after this deleting the values, the array is in the form of sorted order. Okay, we got the sorted order. This is the way how we are going to solve the Hepify method or heap sort method. So I hope you understand this session. Okay, if you have any doubts, please drop the comments. Let's see on next videos.